Welcome back. Now we will study about geographical information system. GIS starts just after remote sensing. If we go by the definition, geographic information system is defined as a computer-based system to aid in collection, maintenance, storage, analysis, output and distribution of spatial data and information. Geographical information system starts after remote sensing once the satellite image is captured by the satellite and is downloaded at any of the stations on the ground, and it's pre-processed for the different geometric and radiometric corrections. Now the satellite data is collected, or simultaneously ancillary data or non-spatial data can also be collected. It refers to both. We collect the data, then the data is maintained, and it has to be stored and put to analysis to generate an output. And once the output is generated, the output can be distributed, uh, and the generated data may be that is to be distributed, may be spatial data, and as well as that may be information. What GIS is going to require? It requires hardware, it requires you the software, it requires you the satellite data as well as the ancillary data. It requires you the people who know how to run software on a given hardware, and who know the different kinds of methods, the different kinds of algorithms, the different kinds of relationships that they are going to use in generating the output. Now in GIS there are two types of data which I talked about earlier in the previous slide. Satellite data, all geographic data that exists on the earth can be reduced to three basic geographical phenomena, can be in principle represented by three things, that is point, line and polygon. If you have any oil well, it can be represented by a point. If you have any house, it can be represented by a point. If you have electric pole, it can be represented by a point. If you have a tree, it can be represented by a point. Now any road can be represented by line, any river can be represented by a line. Likewise, the area under forest, the area under lake, the area under agriculture can be represented by area. So how an oil well or a point can be represented? It can be represented in the form of x and y coordinate. A road can be represented by a series of x and y coordinates, like this is representation of point, and a series of xy coordinates gives you a line. And a floodplain or a forest can be represented by an area entity covering set of xy coordinates, like area can be represented by set of x and y coordinates. It can be, this is the area. So this is how we represent spatial data. Now what about non-spatial data? Non-spatial data includes information about these features, about the spatial data. Now let's name any spatial data. Say oil well. Oil well x and y coordinate is the spatial data. And what about its non-spatial data? Its non-spatial data can be what is the depth of the well, what is the circumference of the well, how much of the crude petroleum is taken out daily from this well, what is the annual production from this well, what are the different physical and chemical characteristics of oil that are found to be in the oil that is taken out of this well. And this was about point. And what about area? If you have a forest area, as the set of x and y will define its spatial data, and the type of forest, what are the species there, what is the slope of that forest, or what is the kind of soil there. This is the non-spatial data. So there is always a possibility that against the spatial data you can add n number of attributes to that particular spatial data in the form of non-spatial data. I hope you got this.